In this video, I'm going to talk through this figure in the textbook in terms of the minimum wage difference in differences example. So if you recall from the textbook, the setup is there are two cities and we observe, let's say, wages for individuals in both cities, both before the minimum wage law takes effect in the treated city, as well as after the law takes effect. So this other city, the comparison city, their minimum wage does not change, whereas in the treated city, there's an increase in the minimum wage somewhere between the before period and the after period. So the treatment is this minimum wage increase, whatever it may be. So thinking of the potential outcomes framework, in the after period, in the treated city, we observe the treated potential outcomes for all the individuals in that city. And so we can average those and get a good estimate of the mean treated potential outcomes for individuals in the treated city. That's this M11 and this value up here. So the question is, what is the average treatment effect for individuals in that treated city, which is called the average treatment effect on the treated? And in order to know that most directly, we would have to travel into some parallel universe where actually this minimum wage increase never happened. But otherwise, everything is identical to our own actual universe. So that's what this word counterfactual down here means specifically in this difference in differences setup, is what is the average wage of individuals in the treated city in the after period in that parallel universe where the law never came into being. Maybe it rained a little more and there were 100 fewer voters and the law didn't pass or something like that. So otherwise, everything is identical except for that one minimum wage increase. So of course, we can't simply travel into this parallel universe to directly observe the counterfactual. So the difference in differences approach is a way to try to reconstruct the counterfactual using this other comparison city down here. So the assumption is that if there had not been the minimum wage increase in the treated city, the average wage in the treated city would have increased by exactly the same amount as the average wage in the other city increased. So the nice thing about difference in differences is that the two cities do not have to be identical. You can see here, if we only look at the before period, the treated city has a higher mean wage to begin with, and that's okay. What it does require is this parallel trends assumption. So here in this diagram, it means this line here is parallel to this line, which is equivalent to saying the increase in mean wage in the other city, the observed increase in mean wage is the same as what the mean wage increase would have been counterfactually in the treated city if there were not a minimum wage increase. So once we have that, we can construct this counterfactual mean untreated potential outcome value for the treated city. We take the observed actual before mean wage for the treated city, And then we're assuming in the parallel universe, it would have increased by exactly what the other city increased by. So we just take this increase, this difference, we add it to the before treated city mean wage, and that gives us the counterfactual mean wage for the treated city, this M10 plus M01 minus M00. So then once we have that, the average treatment effect on the treated, sort of the causal effect of this minimum wage increase is the difference between the actual mean wage in the after period minus the counterfactual. And interestingly, when you plug in the expression for the counterfactual and the actual, if you rearrange it a little bit, you get exactly this difference in differences structure. That's the same exact expression we had for beta 3 in that difference in differences regression model.